Hello, this is Mrs. Pullen for Algebra 2, Lesson 2.01. In this video, I'm going to go over a couple of examples on how to simplify square roots with algebraic expressions. So the first step is to organize your expressions so you see the perfect squares and the non-perfect squares. So I know 54 can be broken into 9 and 6, because 9 times 6 is 54, and 9 is the highest perfect square. The highest perfect square with a variable, when we know any variable whose exponent is an even number, is a perfect square. So when I take a look at x to the fifth, it's not a perfect square, but I can break x to the fifth into x to the fourth times x. Remember, when you're multiplying expressions with the same base, you keep the base and add the exponents, and that's why I could break it apart like that. So x to the fourth is the highest perfect square, highest even number without going over, and what's left over, that x, goes into the non-perfect square. Y to the fourth is already a perfect square, so we don't have to break it up. We then simplify the expression take the square root of the expression, the square root of 9x to the fourth y to the fourth, and we get 3x squared y squared, square root of 6x. So what you do from there is you end up multiplying. The expression on the outside really means 3x times whatever the value is of the square root. So in this case, since I simplified it, I can now multiply this expression. 3 times 3 is 9. X times x is x cubed, y squared, and then square root of x. And that's the answer. Okay, now let's go on to number 9. Again, this 2x y to the second is really the coefficient to this radical expression. So I'm going to just rewrite that coefficient, and I want to simplify this expression to the perfect square and the non-perfect square. So 63 can be simplified to 9 times 6. Whoop, that's not true. 9 times 7. X cubed is not a perfect square, but I can simplify that into x squared times x to the first, because x squared being the highest perfect square in x cubed. And to make it whole, I put x in the non-perfect square piece. Y to the 6 is already a perfect square, so I don't need to simplify that. I will need to simplify, but I don't need to put it into the non-perfect square place. So I carry down the coefficient, the expression on the outside. It's not really a coefficient, just an expression on the outside of the radical. I know that the square root of 9x squared y to the 6 is 3xy cubed, and then that's square root of 7x. I now can multiply the 2xy to the second times 3xy cubed, and I get 6x squared. X times x is x squared. Keep the base and add the exponents. Y squared times y cubed is y to the fifth, square root of 7x. And I'd like to do one more problem in this video. Okay, so how do we add expressions with radicals? It's pretty much the same thing. I'm going to do problem number 11. So how do we do this? I'm going to carry down that coefficient, and I'm going to have to simplify that 200x cubed. I'm also going to have to simplify the 72x. So let me separate that out. Again, I think it's helpful to write this notation on top because it just helps keep you organized. So square root of 200 can be written as 102. X cubed could be written as x squared and x. 72 could be written as 36 times 2. And you can simplify x, so we're going to put in the non-perfect square. Can't make that into a perfect square. So I carry down the negative x squared, and I know the square root of 100x squared is 10x square root of 2x. And I'm going to carry down the square root of 36 is 6, square root of 2x. This could be written as negative 10x cubed square root of 2x plus 6x cubed square root of 2x. And now, since the radical is the same, the only difference is these coefficients, and can I add them together? In other words, are they like terms? And they are. They both have x cubes in it, no other variables. And since the square root of 2x is the same with the same index, we can combine that together. Negative 10x cubed plus 6x cubed is negative 4x cubed square root of 2x. And that's your answer. And I know it's like a little overwhelming when you take a look at it, but just break it down and you'll get it. In any case, I am looking forward to seeing you tomorrow. Have a great evening.